Hello everyone. Let us look into this question. Prove that the area of the semicircle drawn on the hypotenuse of a right angled triangle is equal to the sum of the areas of the semicircles drawn on the other two sides of the triangle. This is the question given for us. Let us start with the given condition. Okay. Area of semicircle drawn on the hypotenuse of a right angled triangle. So let us consider one right angled triangle. So here let triangle PQR be a right angled triangle. Right angled triangle, right angled at Q. Okay, right angled at Q. Now, if you try to draw the figure for this, this is a right angled triangle PQR. Okay, here it is 90 degrees. Now, we have a semicircle on all the three sides. Okay, first on PQ, that is PR, that is the hypotenuse. Next on PQ, and third on QR. We have this hypotenuse here. Okay, so that means for the hypotenuse we have one semicircle, and on the remaining two sides also we have the semicircles. Right. Now what he told here is we have to show that the area of the semicircle drawn on the hypotenuse is equal to sum of the areas of the semicircles drawn on the other two sides. Right. And here also we will consider small points in this. This is what we have to prove. Let us suppose if I take A1 be the area of semicircle on PR. Okay, let A1 be the area of semicircle on PR. Similarly, A2 be the area of semicircle right on PQ, and A3 be the area of semicircle on QR. Right, these are the things. Now RTP, what I have to prove? I have to prove that A1 is equal to A2 plus A3. Okay, this is what I have to prove. Now what you will do here is, in the proof part, we will consider PQ and QR. Okay, these are the things we have. Let us consider PQ as A, and similarly we will consider QR as B. Okay, so now when you start the proof for this, right, let PQ equal to A, okay, and QR equal to B. Then what does PR becomes according to the Pythagoras theorem? PR square is equal to PQ square plus QR square. So from this, PR square is equal to A square plus B square. So from here, PR is equal to under root of A square plus B square. Now even I got the value of PR, that is under root of A square plus B square. I got it. Okay. Now for the semicircles, if you check this semicircle on PQ, A becomes the diameter. Similarly, for the semicircle on QR, B becomes the diameter. And similarly, the semicircle on PR, root under A square plus B square becomes the diameter. Right? Now, for semicircle on PQ, right? So diameter will be A. That means radius, let us suppose just the same thing as we took A1, A2, A3. Let us suppose take this one, since PQ becomes area as A2, so we will take R2 is the radius, is equal to A by 2, right? Now next, for semicircle on QR, so diameter will be B. That means radius will be B by 2. Next, for semicircle on PR, so diameter becomes under root of A square plus B square. So that means since the area we took it as A1, we are taking the radius as R1. R1 will be under root of A square plus B square by 2. Right? So we got up to here. Now let us take area of the semicircle on PR. Okay. So area of semicircle, right, on PR, that is A1. Okay, A1, that is equal to, the formula for a semicircle is half pi r square. So r here it is r1 square. So that will be 1 by 2 into pi into root of a square plus b square by 2 whole square. Right. So this becomes, this 2 and this 2 square will become 4. So I will get it as pi by 8 into a square plus b square. So this is the area of first semicircle on PR, that is A1. Right. So let us name this as equation 1. Next, area of semicircle on PQ. So that is A2. Again same formula, half pi R2 square, right? So what is R2 here? A by 2. So half pi into A by 2 whole square. So this will be half pi into A square by 4. So that is equal to, I will get it as pi by 8 A square. So let us name this as equation 2. This is the area of semicircle A2. Similarly, area of semicircle on, that is QR, right? On QR, of course, that is nothing but A3, that equal to half pi R cube square, R3 square, sorry, half pi R3 square. So here this will be half pi into R3. Here you will have it as B by 2, right? So B by 2 whole square. So I will get this again as pi by 8 B square. Let us name this as equation 3. Now I will add equation 2 and 3. Right. So what was our equation 2? Area of semicircle A2 is pi by 2, pi by 8 A square. And equation 3 is area of semicircle A3, that equal to pi by 8 B square. So when I add these two, that means area of semicircle on PQ, that is A2, plus area of semicircle on QR, that is A3. If I add these two, I will get this as pi by 8 A square plus pi by 8 B square, right? So that is nothing but, when you are adding the areas of these two semicircles, so when I take common as pi by 8, I will be left with A square plus B square, right? I will get this as pi by 8 into A square plus B square. Then what is this pi by 8 into a square plus b square? According to 1, this is the area of semicircle A1. Right? Now here I will write one point. Since pi by 8 to a square plus b square, this is area of semicircle on PR, that is A1. So therefore A2 plus A3 equal to A1, or else A1 equal to A2 plus A3. What is this A1? Area of the semicircle on the hypotenuse, that is PR, is equal to area sum of the areas of the semicircles on the remaining two sides. Right? This is what we have to prove. Right? I hope you got the solution here. We'll meet the next question next time. Till then, thank you.